Hi everybody. In this video, I want to show you how to work with AWS ECS to deploy your containerized application on AWS using the ECS service. To walk you through the steps, I have used the CDK to deploy the network prerequisites, VPC, subnet, route table, internet gateway. And for the creation of ECS, we will create it manually to show you the benefit of using the infrastructure as code tool to deploy resource on the cloud provider over the manual interaction. First thing I will do is go into my Cloud9 project. If you if you are not familiar with Cloud9, Cloud9 is an AWS editor that enable you to build your project and share it with your team for collaboration. So first step I will do is that I will activate my Python virtual environment. So I have already created the stack that contains routes and route tables, subnets, and then internet gateway, NAT gateways, and so on. So let us first activate our virtual environment, and then activate, and then get to the directory, to the VPC directory, right? And list that, and then get in the VPC. So first thing I will do is that I will generate. So CDK is a cloud development kit. It's based on CloudFormation. So first thing you need to do is to generate a CloudFormation template. So your Python, your code, either you write it in Python or Java or TypeScript, it will be converted to a JSON template. So all this code, it will be generated and converted to the CloudFormation. Then when you will deploy this stack, then CloudFormation will deploy all the resources that are within the generated template. I hope that is clear for you. So before generate our template, I need to export my AWS profile. I have already a profile called admin, and then I will type CDK synth. So this command will generate our CloudFormation template. So there is an error. Let me check it. Let me retype the command. So as you can see here, if you're already familiar with AWS CloudFormation, so this is the CloudFormation template that's been generated. And to deploy this one, we use the following command, CDK deploy. So we will wait the deployment for this stack. But before that, it will ask you to accept the changes. So if you're already familiar, as I mentioned, with CloudFormation, when you try, for example, create an IAM role within the template you upload to your CloudFormation, it will ask you to acknowledge or accept the creation of that resource. So the same thing here in the CDK. So to proceed, you need to click on yes. So this is the resource that will be created. So if you face this error, all what you need is just you refresh your Cloud9 and then repeat the same command and it will work. So now it's working as we expected, and then the resource will be deployed. So we'll wait until the deployment finish. So the stack is deployed successfully. If we now try to go to CloudFormation service, we will see that there is a stack that's been created. It's a VPC stack. If we come back and go to the app.py, we can see it is the same name as here. So at the end, when you run CDK deploy, that template delivered to CloudFormation, then the CloudFormation will create the resource on the behalf of the CDK. So the CDK is very handy tool, but I highly recommend you to start with knowing a little bit about CloudFormation before jump and try to start learning CDK. Now it's time to create our ECS cluster. So let's just click on clusters, and to create a cluster there are two options. Either you create it using the Fargate, it is a AWS serverless application, and there is the EC2 instance. So the difference between two of them, for example, if you want to have more control on your EC2 or the instance that hosts your tasks, then it's better to go with the EC2 instance option. If you don't want to worry about the infrastructure and you don't want to manage it, then you can go with Fargate. So Fargate have one advantages, many advantages, and one of them is the flexibility of the scaling. So when you use Fargate and like you want to spin up 3 or 5 tasks for your application, then that flexibility you don't need to go, for example, to auto scaling group and then increase the number of maximum instances that should spin up and so on. All what you need to worry about is your application and the number of tasks that you want to spin up. But with ECS, with EC2, for example, if you want to spin up much task and then you don't have enough resource, then I mean the resources that are available on your EC2 instance, you need to go and then what we call it, increase the number of the maximum number of instances that the auto scaling group should spin up, or you can use CloudWatch alarm to spin up that, or you can have like create a CloudWatch alarm, then you can attach that or you can connect that with the CloudWatch event, and once that alarm triggers, then that CloudWatch event will call a Lambda function that that Lambda function can talk to the auto scaling group to spin up much instance. I hope that's clear for you. So first thing I will start with is to create the cluster, and I will choose EC2 instance plus networking as long as I have already my VPC, my subnet, and so on. So ECS cluster. We'll scroll down, and then for the EC2 instance type, make sure to choose the T3 type or the T3 class of the instance. Otherwise, it will not work for you. You need or you must to use the T3 class or above. If you choose T2 class of instance, then it will not work because T2 does not support UEFI EI boot mode. So I will scroll down and then choose T3 medium, and they will keep the default EMI. And then for VPC, I will choose mine. For subnets, I have many subnets. I have created them, but I will choose the ones that's called public. So I have public subnet 2, and the other one I should look for it. It's public subnet 2 as well. So I will scroll down, and then for security group, I will choose one I have already created. It's called ECS cluster security group. We'll scroll down, and then I will enable container insights. Then I click on create. So once we create the cluster under the hood, this will create an ECS instance IAM policy that will be attached to this ECS instance role. So it will give permission or create a profile for our EC2 instance that will host our task to make AP calls on our behalf. And this cloud formation stack will create under the hood the auto scaling group and the launch template configuration. If we click on it and go and check what is being created by this cloud formation stack, we can see in the resource we have two resources have been created: the auto scaling group and the launch configuration template. Let me come back and then go to the next step is create task definition. So I have already created one, but I will show you the steps to create that on your own AWS account. So you choose EC2 type and then give it a name, and then a task role, then a network mode. So this task role, we have two tasks here. We have task role and task execution role. This task is used by the container itself. Like for example, your application is talking with S3 or it talk with DynamoDB. Then your container or your task where your container reside. So if you're already familiar with Kubernetes, then the task is like a pod. A pod can has one or many containers. So the same thing with task. So a task can have one container or more. And we assume that within the container that is inside your task, there is an application that talk with DynamoDB. And this container that is inside your task, to be able to make that REST IP request, it must have this role or has a permission that will be attached to this role. I have already one, and I call it ECS task role. And for the task execution IAM role, this role is attached to the ECS agent. So let me come back to Kubernetes and tell you that this ECS agent is look like the kubelet. It is responsible to talk with the Docker daemon to tell it, please, can you spin me up a container that has these images with this resource? So the same thing. And this ECS agent, it's like push logs to AWS CloudWatch, and also it pull images from ECR. And to be able to do that, it must make a signed HTTP request. And to sign that, it needs a credential. So at the end, it needs to assume a roles. And that roles must have permission to talk with either CloudWatch or ECS. Or the ECR. Or for example, if you want to pull your image from a private registry, then you need to provide, like in Kubernetes, you create a secret and you provide your username and password of your registry. So here you can also do that via creating a secret on the AWS Secret Manager and then provide username and the password. Then you tell to the task, please, if you want to use the private registry, then go to the AWS Secret Manager. And this task to be able to pull those credentials, it must to have the permission to the secret manager. So to allow it to do that, we need to add a permission to this task execution role. I hope that's clear for you. And here in the task size, we can give it like 1 giga. It's based, it depends on the application or how much you guess that your application will, how much resource it will use. So I will go with this one and then I will add container. Here, this is my container. So if you're already familiar, I come back again with Kubernetes. When you create your YAML file for your deployment, then you will have deployment, replica set, spec, then you have the container spec. So in the same thing here, in the task, there is a container section. And then I will give it Nginx. I will scroll down till the end and then click on log configuration. Scroll up and then add another thing is port mapping. Sorry, HE. So anytime when you will use your public IP address of your EC2 instance and you send a request on the port 80, that request will be mapped to the container on a port 80. If you know about Docker Bridge network mode, it is the one that we used here. You can scroll down, keep everything as a default, and then, sorry, I need to give it a name and we call it ECS task. And then create. So in Nginx ECS task, then I will create an ECS service. So like we can run this task, right? Like in Kubernetes, you can run a pod without using the replica set. But what is going to happen to that pod is like, for example, if it is shut it down, then it will not start it again because there is no replica set. The replica set is like every time it will look for the current state with the desired state. And for example, if that pod is shut it down, then in the current state it's 0 and in the desired state is 1, then the replica set will spin up the pod. So the same thing here, we can run this task, but if this task is shut it down, it will not run again. So for that, we need to create it within a service. So imagine a service is like a replica set. And then we'll choose EC2 type. And then here I will choose, yes, this task I have created. And then for the service, I will call it SVC. Scroll down and then give it one number. One, I want to spin it only once. This other option, I will cover them later on. But in this section, I won't just go with the default ones. Give it a next. I will not choose load balancer. Click on next, next, and then create service. And then view service. And then I will refresh here. And then our task is spin up via the service. So it is independent state. We'll wait until it be in the running state. And now I need to come back and go to my EC2 console and then go to the instance that's been created by the ECS cluster. So this one, and then take its public IP address and then paste it here. And then we can see that the Nginx work successfully. We can create a record name for that as well, and we can do that via Route 53. We can go to Route 53, then create an alias record for our public IP address, but this is not the recommended one. It's better to use load balancer rather than using this public IP address or attach an elastic IP address to your instance, because this public IP address, it will be changed once you will stop and start your instance. So every time you start your instance, you need to go to Route 53 and change your record value. So hosted zone, then go to your public hosted zone. I have already three ones. This one are private and this one is public. So let me create a record and then I will call it ECS Nginx and then paste the IP address, sorry, here, and then create our record. So it took about 1 minute to be propagated to our DNS servers. If we come here and start to check and wait a little bit, yes, now it's working. As you can see, it's working. And if you use like load balancer in your ECS service, then you can use the HTTPS on the port 4043, and then you can upload your AWS ECM, your certificate manager that will sign it your domain. Once you buy it from Route 53, you can sign it and you can have an SSL for it. So I will not cover the SSL in this section, but if you are interested in that, you can let me a comment and they can make more video about this. So in the meantime, I am preparing something very handy for you, is how to create the ECS, all that using the CDK. I have already started that, and they will create a pipeline, how to create cloud formation, how service discovery, load balancer using ECM to have the SSL certificate manager integrated with our load balancer to have HTTPS. So if you like this video, give me your feedback in comment, share it with your friend, and if you have any question, you are very welcome. Thank you for your watch.